Hello, today we are going to see how we can perform analysis of an assembly and weld in Creo to perform just to simulate such a beam. It's a beam that is have a load and fixed onto these four holes. This beam is welded on. Let's see how we can model this in Creo. At the same time, you're going to see how we can perform analysis. As you can see, the beam, it has three parts. These parts are welded on. Let me just cross here. Once we have weld here, and here is where we are applying the load. Here we are going to hang the load. Let's see how we can model these three parts. Then we can perform analysis. I'm going to start with a new assembly in Creo, and I'm going to insert first part. Call it, maybe you can call it ground, the one that will be fixed like that. And you can use default for now, then create the plate welded on, and the plate as well. Again, just use the default constraint. Lastly, let's create a C channel beam like that. As well, use default constraint. We start by the ground. You activate the ground and you select you can activate the planes here. On the right plane, select extrude. We're going to use a center rectangle like that. And this, let's make them equal. Let's use a small one, 200, like that. And for the size, use 10. You go the other direction, like that. You can use round, let's round by 15. That's okay. Let's control, select the other edge. Lastly, we can now extrude the mounting holes. Can just do create a rectangle square like that. And for construction, because I need circle there, with a diameter of 20, and extrude remove the other direction. That's our base. In this ground, you can assign material. Yeah, let's go back to assembly, and we can assign material there. Let's go to the legacy and assign steel and say okay. Next, activate the welded on plate. Again, go to the right plane and extrude. You use a center rectangle like that. Maybe that is fine. Make them equal 120 like that. Then extrude by 10 like that. Then use round. Let's round by 5 like that is done. Go back to assembly, and this plate assign material as well, steel. You can assign some appearance to differentiate, maybe like that. Lastly, let's activate the C channel here. Since this one is 10, if you go to the right plane, insert a plane at 10, because I don't want to mate to assemble. Yeah, it will be 10 away, therefore it will be on this surface. Yeah, therefore on this plane here, extrude like that. Again, center like that. Maybe let's dimension the size, maybe to be 10. Yeah, this to be 50. Maybe you can use any value you need. Then I need to trim here like that. Oops, I need to connect here to that, like that. It can be, let's make it 60, make it 65. Dimension doesn't matter, just want to make it fully constrained like that. Then round inside can use maybe 5. New set outside can use maybe 8. New set this here and this here, this and this as well, can make it maybe 4 like that. Can go back to the before we can let's now create a hole first here. You can use instead of extruding, you can use hole command from this face to this face here. You can say create a hole of maybe 12. Let's go with the 12. Yeah, let's go with the 12, maybe somewhere there, maybe somewhere there. You can see the hole doesn't go through. Cannot go back here. You can edit, and this is the depth. You can go through like that. Otherwise, you can also define the here depth here. You can say to reference to this face as well, so that once you update your parts, the whole always updates. But now I'm just doing this because it's a quick demo. Lastly, need to define the material for this. I'm going to use everything to be steel for demo purpose. We have defined our part in our material. Those are the models we need. Now, next is we need now to define the weld. Remember, we are going to weld these 3 parts together. We are going to, this surface is going to be fixed to the ground. We are going to apply load here. Maybe I can open up this. Let me just open up this, show you, so that you can sketch the load for you to understand what I mean. As I said, if I go to the front here, I can sketch on the front plane. I can create this as my reference, and I want to use a center line through there because I want to create a point there. My load will be at that point. Yeah, I can say I'll hang a load there like that. That will be my load. I can also on this, let me just, I'm going to use some rope to connect my load to the holes. Therefore, I want this one here to create a point in the center again here. point on the center. Then I want to create a curve from this point to that point, another curve from this point to that point, just to show you that the load will be applied like that. You can see that's how the load will be applied. I should open this. Okay, next is now we need to define weld. If you go to application here, you can see welding, and we're going to have a fillet weld between this and this one side, then another weld between this and this on the both side. We call it other side. Therefore, you select fillet weld. We're going to have double and single. For now, let's start with a single because we want to define weld between this surface and this surface here. Okay, I'm going to use a weld of 4. 4 is a fillet weld, because now, as you can see, this one is a surface. Let me just create okay, so that you can see what I mean. If I go to view, let me just section here. You can see this one is a surface, but I want this weld to be a solid. Therefore, you just go to options here and say weld geometry to be a solid. For the material, we will define later, or you can define here if you want, but I'll show you how to define it later. Again, go to application, go to welding, go to fillet. I'm going to use double-sided because here it is a two-sided arrow side, this surface to this. Therefore, here select the surface, here select the surface, and get weld on this side here. 4, let's use a 4. Other side, this side to this. It's really good. You can see we are getting another weld there. You can use options solid like that. If you want to change the size, maybe to make it a little bit bigger, you can go to 5 if you want. You see now we have weld there defined between all these 3 parts. Okay, if you now go to simulate, this first for perform what we call contact analysis to see what is happening here. If you go to review geometry, apply, you see there's nothing happening here. You see now this one here, it states that the Creo assumes this part is boarded. You can see boarded to this, while this is boarded to this, but they are not boarded. It assumes these parts, since they are touching, they are boarded to each other. Let's fast for, we do not need that boarded connection here. If you go to interface here, I want to create what we call free interface between component. This component to this component, it should be free. Again, another interface, free between component to component, this to this, it should be free. Therefore, we have that interface. If you go to review geometry and apply, you can see now all these parts are free. You can see there's no, everything is white. White means all are solid surfaces here. They are free, they are not touching. We need not to connect them using weld. Therefore, we are going to go to the weld here, weld, and we're going to create a weld feature because the weld is already existing, and select the first one here. Remember we said for thickness here, but we can override material. Therefore, more, go to legacy, as let's use steel as well. For the material, remember you use the thickness of 4. This 4 you cannot override unless you change the value. Again here, weld, We are saying it is a weld feature with this one here. Remember we used 5. Can override material, select steel. Okay, if I go back to review geometry and apply, you can now see we have this means they are bordered surface, this color pink or purple. Pink means bordered interface. It means this weld is bordered to this and as well bordered to this. This is called the, you can see the weld how it is, and this one is a weld surface. You can see a weld surface with cyan color. Okay, um from there, if you go back home, you can assign the material if you want, but we already assigned the material. You don't need to repeat this step because you can see material is already assigned, but it's okay to be sure you have already defined your material here, and also make it a good habit of renaming your features there, material. Okay, make it a habit of renaming whatever you create here, like here 4 mm weld. Here I could have said 5 mm fillet weld. Renaming is okay, but now this one is a simple model. I don't need to go to that detail. Now if I go back to the, let me go back to the refined model here. This called autogen. Autogen is used to create mesh. You can use the default settings now. These are the default settings. If you don't want to see these dots, you can go here, go to mesh and mesh point. Okay, but most of time I like refining the weld mesh, because now I like refining this weld, at least to refine the at least weld. Therefore, let's close this one here. Let me go to gem here, control maximum element size for a surface. This surface here, you can use control to select all these surfaces. I like refining my weld mesh, because if you refine the contacting surfaces, you get more accurate results only for the contacting surfaces, so that you can have more nodes formed on the contacting surfaces here, and you can give it 2. I want to use a lot to save some time here. If you now create this mesh, let's see, you see now the mesh for the weld solid is will be 2 mm smaller in size, so that you can get more accurate results on the contact surfaces here. But for the rest of the geometry, you don't need to refine. You can see now a model has refined. You don't need to save this. Just want to show you that it is possible for you to refine the mesh. Then we need not to define the boundary conditions. That is, if you go home, you can define these 4 holes are fixed. If you select intent, because these ones were used, I used extrude. Therefore, if you select extend, you can select all of them at once, and you can fix all of them. Rotation don't need, because this is a 3D. If you fix this one in a 3D XYZ, you don't need to fix rotation. But when you're using a shell or 2D, you need to fix rotation for a 2D shell. Then we need to define load at this point. You go to refine model, mass. I need to define mass. Mass is a point, single point. That point there is let's use mass per total mass. I want to use kilograms 50 or 100. kilograms at this point here, like that. Now I have my mass. My mass is there, but we need to connect this mass to these holes because we said we are going to hang the mass onto these holes. Therefore, we're going to use what we call weighted link to link these surfaces. Let me first hide this. To link this whole surfaces to the point mass. Therefore, you select the weighted link. You have to select this point here. To can select intent and use this surface here. Intent. Okay, how to select surface here and select intent, that surface. Degree of freedom, everything to be free because we are going to hang mass there. Then after hanging the mass, we need to apply what? Gravity. Go home, define gravity. For the gravity here, instead of defining the value, you can say gravity. It is going to use the units, your units, to give your gravity instead of now converting your gravity to inch per second squared, just like gravity. But you can see there's a negative y. Y is facing downward. You can see here y is green facing up. Therefore, gravity is -1. Like that. You can say preview. You can see there's an arrow here formed for the gravity. Like that. You see this arrow means gravity. Lastly, you can go now to analysis, studies, file, new, static. You can give it a name. You can use a single pass. Just leave all this as default. I won't run the model because I have it already here. That's my model already. Just go to application. Let me just open the results app. Here, we add static. Once you run it, you're going to see, you press this green button to run, you're going to see completed. You now can select weld static. You can get results from there like that. The quantity is displacement. You can use either stress, displacement. Display, you can say continuous tone or not. Continuous tone means that the color map of the displacement is continuous, not discrete. You can use deformed, and you can give a scaling factor of deformation for ease of visualization. You can now animate if you want, and you can increase the frame rate, the rate at which you are going to animate. And you can use graph, model, vectors. Fridge is the common one used. Then say okay. You can see, as we expected, when you apply the load here, that is how it's going to deform. If you don't like this color, you can go to format, edit. You can change color here to the preference you want. Like that. I've just changed this the minimum values here because they are not changing. Okay, yeah, don't save. Yeah, something else I want to mention to you is about p level. P level is a Creo uses what we call p level type of elements. These are the elements that use polynomials instead of actual other instead of other type of elements that are known by other FEM or FEA softwares. If you see okay, you see now we have reached a P7. P7 is order 7 for us to get convergence of our element of our analysis. Also, that one is a good check you can do to see if your results converged properly. Lastly, you can perform stress analysis here. You can see stress continuous. If you don't want to see continuous, just select it. You can show element edges there. You don't need to animate this one here. You can overlay deformed if you want to overlay two models. deformed and undeformed. When you say so, you see now this is deformed, this is not deformed because you have said overlay. That's how you can perform analysis. I hope you have learned something in this video. Let's meet in our next videos and make more advanced analysis in Creo. Thank you and see you next time.